To attempt the question above, we'll be making use of the dilution formula, and that is C1 V1 equals C2 V2. So C1 here refers to the initial concentration, V1 initial volume, C2 final concentration, V2 the final volume. And in some cases, instead of C1 you can see M1, that is the molar concentration, and V1 it can be represented with D1, that is the diluted volume. Before we proceed, we'll write out the values given in the question. So let's start. C1, from the question, the initial concentration is given to be 2.0 mole per dm cube, and the initial volume, which is V1, is given to be 2.5 dm cube. So for C2, the final concentration, that is unknown, and that's what we are being asked to calculate. Then V2, the final volume. The final volume will be equal to the sum of the initial volume with the volume of water added. I think the final volume was stated, we might not need to do any kind of addition, but in this case we were only told that the water was added to the solution. So to get the final volume, we'll be adding the volume of water that was added to the initial volume of the acid together. So that will be 10 dm cube plus 2.5 dm cube, which is equivalent to 12.5 in the unit dm cube. So from here, let's proceed to solve for C2, the final concentration. So we'll be making C2 the subject. C2 equals C1 V1 divided by V2. So let's substitute the values. C1, that's 2.0 mole per dm cube, multiplied by V1, 2.5 dm cube, divided by V2, 12.5 dm cube. So calculating this, we have 5 divided by 12.5. Do not forget the unit here, mole per dm cube, and this is equivalent to 0.4, our unit mole per dm cube as well. This will be serving as the final answer. So with this, we've come to the end of the solution to the question, and we've gotten the concentration of the final solution to be 0.4 mole per dm cube. Do well to subscribe for more if you find this video helpful.